Hello, and I'm going to be talking a little bit about outliers today for the statistics class. And I'll just start with a fun quote from Malcolm Gladwell, who's written a very interesting book on the topic of outliers, where he says it is not the brightest who succeed, nor is success simply the sum of decisions and efforts we make on our own behalf. It is rather a gift. Outliers are those that have been given opportunities and who have had the strength and presence of mind to seize them. So he's written a book particularly on people who have succeeded well above and beyond what you would expect for them. And so it's just an interesting concept when thinking about outliers to think about them in terms of not just statistical outliers, which we will, but also just the world is full of outliers, and they make the world an interesting place. Okay. The thing that happens though in statistics is you get an outlier, something like this picture right here, where everybody else, the little x's, they're all together. You can predict them, which is what statistics is all about. You can tell what's going to happen. And then you have this one person and they just kind of don't fit with everybody else, right? And it makes your data get wonky. And you want to ask the question, where did you come from? So for an example, let's think about if you imagine a class and you look at the shoe sizes of the class, right? And it's going to look pretty similar. Maybe you have 1, 5, some 6s, quite a few 7s, 8s, and 9s, a couple of 10s, not too many 11s and 12s. And it kind of makes a bell curve for the class of shoe sizes, right? Of a typical sample of people, adults. However, if you have something unusual in the class, like Shaquille O'Neal has a shoe size of a 20, which is just gigantic shoes, right? Or somehow an infant made their way into this class, maybe your genius child or something, and they have an infant size 11, right? Which would have to be measured on some other scale, but it would throw off the whole thing, right? And it makes for a non-normal lopsided bell curve. So the thing to remember conceptually is we want something that creates a nice bell curve because it uses probability. And so if you have a single outlier, even in a relatively small or medium-sized data set, it can actually change all the numbers. The mean especially can move and give some kind of what we would call a false outcome because the outlier is not working on probability and those principles that everything in statistics works with. I often think of this also in terms of like, you know, there are people sometimes who are just different than everybody else, and they make the world a much more interesting place, as Malcolm Gladwell talks about in his book, but they also make the world a more unpredictable place. Right? So if statistics is about trying to predict kind of typical samples and typical humans, we value the unusual. I certainly do, and the outliers, but at the same time, they make our numbers get nervous. So what do we do when we find them? Well, you have to have kind of a standard for defining what an outlier is. We'll do it in different ways in this class. Search and destroy and the frequency analysis is one way. And you see the little great job star there. In my class, for Dr. Ripley's class, we often use anything that's outside of 3 standard deviations from the mean score as an outlier. And just because we have to have some kind of common thing in the class so that we all get the same results when running a test or a homework or something, and so that I know what you're doing. But there are other ways in frequency analyses that you might decide, hey, this really is an outlier. On a univariate level, I'm going to throw them out. You can also get outliers on in a histogram, right? So you can kind of have a histogram that kind of looks like a bell curve, and all of a sudden you have like one spike. Or it's kind of going like this, and it's blank, 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 and then you get one person way, way on the end, on one of the ends of your bell curve, and you might decide based on that. Or you might look at a normality plot in SPSS and have it look like that. So there should be a standard. For instance, like I said, 3 standard deviations from the mean of the entire sample would be one that I commonly use just because it's a simple one to find. Okay. What are you going to do if you find univariate outliers in your data set? So one of the things to do is if it's your real data and you're doing your dissertation or something in the future, just double check and make sure your data was entered correctly. So like if somebody typed in 21 as a shoe size, right, you might go back, if it's possible, to go back to the raw data, right, to the original data that you obtained and see if it was actually supposed to be an 11, right, or something like that, that data entry wrong. So check that. Then the next thing to do, if you can't check original data, for instance, like that's not possible, or it turns out, yeah, there is a shoe size of 20 in this sample. Okay, then you eliminate it, right? So the number one thing to do, the little star there is great job, is to go ahead and just delete that case, and you'll get rid of that case or that point of data that's an outlier from your data set. You make a little note on it and report that, obviously. You can do something that pretty much everybody in my class always says is cheating, but it's really not cheating. It's really saying, hey, you know, I had somebody come into the class and my sample had a shoe size of 20. What I'm going to do is I'm going to transform that number. I'm going to change that number from a 20 down to a 14, which is still very high, but not so high that it throws the entire data set off. So you might put them at the, you know, very height of everybody else. The only time you would do this is if you're dealing with something like a very small data set. Maybe you only were able to collect 30 participants or something, and you really can't throw anybody out and still finish your dissertation, you know, things like that. But the main thing is if you do something like that, you can transform the data, you just need to report it and it needs to be logical. So, and that would be a logical thing to do. You can do all kinds of much more crazy things like transform the entire variable, although that doesn't typically work, but it can sometimes. Other times you might decide this variable has a lot of outliers in it and it's just kind of wonky and I'm going to go ahead and toss it out. I don't need it for my analysis. It was kind of an extra variable anyway. So sometimes people do that. So the fixed whole variables thing we will not be doing in my class, but I just want you to be aware there are kind of other options when dealing with univariate outliers. All right, but outliers are not only on a univariate level, they can also be on a multivariate level. You'll notice all along here, we've been dealing with continuous data. You can't really have an outlier when you're talking about something that's categorical, right? So like you can't have an outlier for nationality or something, right? Like you can have an unusual answer, but it's categories, right? Like someone's a citizen of France or Great Britain or Germany, right? And you're looking at those, and maybe like we only had one person who was a citizen of Turkey in the study, so they're unusual, but it's not an outlier, right? Because there's not a bell curve in terms of like your citizenship, right? But you can get an outlier on any continuous variable. So anything that's multivariate, however, you can get continuous on them too and have problems. So one is a bivariate. This involves two variables together. They can either be both continuous or one continuous, one categorical, right? When you put two variables together. And there are 4 strategies to examine them visually to kind of get a visual and then potential cutoff scores. One is just to look at a bivariate scatter plot. And so this would show you, you know, something that looks like hopefully a blimp or, you know, a line of data kind of going together. And if you have one that's way outside of where everybody else is, you might kind of visually decide, hey, that case is going to get tossed out. That's not the best way to do it, but it can be done. Box plots are often done also sometimes in psychology, and you'll get box plots in SPSS and they'll show you where the outliers sit and they'll give them little codes on there and tell you which case it is. Stem and leaf plots are something that we use in my class to identify outliers by category. So box plots and stem and leaf plots both have a categorical variable and a continuous variable. And so stem and leaf plots will give you a sense of where the outliers are by group. So if you have nationality and you have Germany, France, Turkey, and Great Britain as 4 categories, and then you're measuring them on I don't know, attitudes about immigration, then you might find in one country, just a single country, you have an outlier because you basically look at them separately for their outliers, right? And so stem and leaf plot will do that, and we'll go over that in class and how to identify an outlier within a particular category of your data. Finally, the gold star goes to Mahalanobis distance, which is 3 or more variables that are all continuous. So all continuous variables, when you're doing that, which in my class we do with regression and MANOVA, if we have 3 or more continuous variables in the MANOVA or MANCOVA, or ANCOVA could maybe do it if you have some multiple covariates. So when we get a little further along, we'll be running Mahalanobis distance to look for outliers in the data. All right, this is just a picture of a scatter plot that shows you the bivariate outlier. So I like to think of this as people's religious commitment, maybe along the x-axis, and church attendance on the y-axis, okay? And for the most part, when people have low religious commitment, right, on the x-axis, then they also have low church attendance on the y-axis. And then it kind of goes up from there. The more religious commitment they have, the more church attendance they do, all right? And then pretty much everybody's there. But then there's this one outlier. You can see that person sitting out there. What is going on with that person? They have low religious commitment, but very high church attendance. What's happening? So this is that one person who maybe, they attend for grandma, right? Like they go every Sunday, they go for grandma, but they don't believe, that's not like their belief system. They have very low commitment to their religion. So for that, you might have, I call it the I'm going because of grandma kind of reasoning there. So that's what a scatter plot would look like. And if you look here, the red line would be the regression line that would be on this set of data. So if you plunked a line down the middle of the data to try to measure it, the red line would be without the outlier and the blue line would be with the outlier. So you can see how much the line can actually move just from a single outlier in a small data set, particularly like this one. Very large data sets, it's not such a big deal. All right, now if you have a categorical and a continuous variable, and so you're wanting to look at outliers by each of the categories. So before I talked about like 4 different nationalities, and you want to look for outliers within each of the 4 different nationalities, or maybe by males and females, right? And you want to do height distribution for males, height distribution separately for females. So look for whether male, female predicts height. It's a very boring question, but works for our purposes. So you can do something called a box plot. This is what a box plot looks like, and you get it as SPSS output. And it's just a picture of the data, and you can see these that are sitting way out here. I'm gonna do this one sitting way out here like this, right? Maybe these couple here. This one's just an oddball one with 4. It's the whole thing is just very strange. It's a very small plot right here, and then a lot of outliers sitting there. So something's up with that particular machine. For machine 3, it looks like we have 1 outlier sitting up here, right? And for machine 2, it looks like we have 2 outliers sitting up high on that one. Excuse me. Well, on machine 1, it looks like there is no outliers for that one. Everything falls within the, the range there of energy output. So you can kind of get a sense here of what that looks like. And I think that's really helpful for folks. All right. To see the box plot, but we don't use box plot too often. It's better to use stem and leaf plots, which we will go over in SPSS lab in class in detail. And we will also go over Mahalanobis distance and how to do that in class. Those are not so easy to show on a lecture. So we'll cover that there. So these are the take homes from the mini lecture on outliers. 1, outliers are a major assumption for all statistics that involve continuous variables, and they may indicate an error in sampling or measurement. So you may have something, Shaquille O'Neal wasn't supposed to be in your study, right? Or you measured something incorrectly, or you wrote it down incorrectly. Some kind of error could be indicated there. They do exist only for continuous data. They can be univariate, so a single variable, bivariate with 2 variables, or multivariate, which would be 3 or more variables. What you do when you find them is you search them out and eliminate them. On occasion, you might transform, but for the most part, you delete the data that is suspect as an outlier. In class and SPSS with me, we often use these things to determine who to kick off the island, all right, or which outliers to eliminate from our data set before running further analyses. One, for a univariate level, it's things that are 3 standard deviations from the mean. For any data that has a categorical and continuous, right? So ANOVA will have categorical continuous variables together. We would run stem and leaf plots for my class, and anything with 2 or more continuous variables, you can run Mahalanobis distance for those. So thank you very much.